Bonsoir Montréal-Python. Good evening Montreal-Python. And welcome to Montreal-Python 91 Exotic Viking. Bienvenue à Montréal-Python 91 Viking Exotique. Ce soir, nous avons une soirée pas très chargée. Ça nous laisse plus de temps pour le 5 à 7. Et laissez-moi vous parler du programme pour la soirée. Mais avant tout, je dois vous mentionner qu'on a un code de conduite à Montréal-Python. Et le code de conduite, c'est très simple. En gros, ça dit « Soyez très canadien ». Soyez poli et courtois. Et si jamais il y a quelque chose que vous voyez pendant la discussion ou quoi que ce soit qui vous semble pas poli et courtois, trouvez-moi, Yannick ou Duc, sur Slack. Et puis, on va se faire un plaisir de régler ce problème-là. So before we go any further, I have to mention, we have a code of conduct here at Montreal-Python. It basically says that we should be all very Canadian, polite and courteous. If you see something that doesn't feel polite or courteous to you, well, find me, Yannick or Duc, and we will do our best to resolve that problem. Our program for tonight. Let me change my slide. Our program for tonight is very simple because unfortunately, two of our speakers tonight could not attend. That would be Yuri and Daniel. They will join us at a later meeting sometime later during this year. But tonight, Noah Gift is going to give us a presentation on MLOps. And then we're going to have our virtual happy hour, which is basically just a video conferencing. You grab your favorite drink and we chat about whatever is exciting in our lives. Alors, notre programme ce soir, car malheureusement, nous avons eu deux annulations de dernière minute, sera simple. Il va y avoir Noah qui va nous parler de MLOps. Par la suite, on va avoir notre apéro virtuel sur Jitsi, simplement une vidéoconférence. On va aller chercher notre rafraîchissement préféré et puis on va discuter des choses intéressantes dans notre vie. Yuri et Daniel, qui ne pourront pas présenter ce soir, vont présenter plus tard pendant l'année. On vous tient au courant de comment ça va se dérouler. Autre chose, il va y avoir une soirée de programmation lundi prochain. Et donc, nos soirées de programmation, si vous vous souvenez, c'est essentiellement des soirées de pair programming légèrement orientées et avec un sujet directeur. Donc, on se retrouve ensemble, on ouvre un éditeur partagé et puis on se met à coder. La soirée de lundi prochain, ça va être les concepts de base, donc programmation assez rudimentaire avec Python. Et on va voir les choses de base, les types, les boucles, ce genre de choses. Donc, si vous n'êtes pas super familier avec Python, eh bien, joignez-vous à nous. Ça va être principalement en français, mais on accepte bien entendu les questions, les commentaires en anglais. Il va y avoir Montréal-Python 92, Wi-Fi dentaire le mois prochain, le 21. Et une présentation qui est déjà confirmée va être Guillaume Bélanger, qui va nous parler, intéressant, de gestion de réseau cellulaire avec Python. Ça me semble complètement fascinant qu'on puisse faire ce genre de choses-là avec Python. On a notre page Facebook, notre page LinkedIn, on a notre calendrier 2022 qui a été mis à jour. Je vous invite à le regarder. On va avoir nos rencontres mensuelles. On va avoir des soirées de programmation mensuellement. On va avoir un sprint de traduction vers le mois d'avril. Et autre chose, là, si vous voulez qu'on fasse d'autres choses, bien, ça va nous prendre quelques bras additionnels. Donc, on vous invite à amener vos doigts qui tapent vite avec vos claviers et à vous joindre à notre équipe. On a gravement besoin d'un nouveau trésorier. Pierre, qui était notre trésorier pendant plusieurs années, doit malheureusement quitter son poste et puis ça nous prend quelqu'un pour payer nos factures. Je suis tout à fait pas qualifié pour faire ça. Alors, si vous avez des aptitudes à payer les factures ou à partager ce que vous aimez faire en Python, eh bien, joignez-vous à notre équipe. Contactez-nous sur Slack ou notre adresse le courriel est posté un peu partout. Et on vous attend à bras grands ouverts. OK, other stuff. Next week, on Monday, we are going to have a programming night. So our programming night is basically a lightly directed pair programming night. We're going to have a shared text editor, and we have a topic each night. And next Monday is going to be basic Python concepts. We're going to see types, loops, things like that. So if you are just starting in Python, next Monday, join us, and we're going to code together. It's going to be mostly in French, but we always accept questions and comments in English, of course. Next month, on the 21st, we are going to have Montreal-Python 92, dental Wi-Fi. And one presentation is confirmed. It's going to be, I'm blinking, Guillaume Bélanger. Je m'excuse, Guillaume. And he's going to talk about management of a cellular network with Python. I had no idea we could do that. So that's going to be very interesting. Follow us on LinkedIn and Facebook and all these places. I've posted a link to our 2022 calendar. We have a lot of events. If you would like to see more events, well, we need additional help. So bring your fast fingers and your keyboard and join us and help us to put these events together. We really need a new treasurer. So treasurer is really simple, is the person paying our bills. I am totally not good to do something like that. So if you are particularly good at paying bills, well, please join us. That would be great. And last thing, I'd like to thank FJNR. FJNR is hosting our video conferencing platform for our happy hours, and we're really happy that they provide this service. Now, en français, je reviens avec la langue de Molière. Ce soir, nous avons l'honneur de vous présenter un invité qui est un homme avec une coupe de cheveux absolument élégante. C'est l'auteur de 3 livres sur la programmation en Python et sur l'apprentissage automatique. C'est un professeur adjoint à l'Université de Duke qui nous parle directement de Caroline du Nord. Tonight, we are so honored to present you a man with an absolutely elegant haircut. He is the author of 3 books on Python programming and on machine learning. He's an adjunct professor at Duke University and is talking to us directly from North Carolina. Noah Gift, how are you tonight?
Doing well. How are you doing?
Doing great. Excellent. So Noah, the stage is yours.
Great. Yeah. So we're going to talk about MLOps tonight, and I have some materials, prepared where I think it will be interesting for people. And I'm also happy to talk a little bit about some of the new things I'm doing with MLOps. So I think what's very interesting about MLOps is that unlike other topics like, let's say, I don't know, web frameworks or command line tools or cloud computing or something like this, where those are definitely rapidly moving. This is so rapidly moving, it's like you're on lava or something there's so many things happening with MLOps. So I'm going to definitely cover some, I think, very interesting theoretical concepts and hands-on concepts, and then do a little bit of coding as well. And then I'm also happy to talk about some of the new things I'm working on with MLOps. I think it's a very interesting area for people to get involved in.
Excellent.
So would you like me to talk about anything else before I do a presentation, or how would you like me to proceed?
It's your time. Use it however you feel is gonna be best to communicate your excitement about that topics of MLOps. I personally know very little about it, so hopefully you're gonna be able to give us a quick overview and then take us wherever you want.
Yeah. Let me just go ahead and share my screen then real quick, and I can just get started with some slides. If anybody wants to interrupt me, they're welcome to as well. Let me just go here, and we'll start with this, and you should see that. Perfect. And then I'll go into presenter mode. We'll go ahead and do this. Yeah, so the idea here with MLOps is I should explain my background a little bit, because I think it will help explain why MLOps is a reasonably good fit for my background. So I started almost 20 years ago, actually, maybe even a little more than that, in building animation pipelines in the film industry. And it's interesting because a lot of people that I've talked to in the last maybe 5-10 years, film comes up and they're like, well, what do you do in film? Well, we built data engineering pipelines. That's what we did in film. So, pipelines in Python have been around for a long time. And I think if companies want to hire some of the best, I would say, data engineers around, look for film people, because film people have been building data engineering pipelines on large scale Unix clusters for a long time. and it really was a great experience for me to work at Disney. I also later worked at Sony ImageWorks on their first 3D animated pipeline. I used to play basketball with Adam Sandler at lunch. That was kind of fun. He's actually a pretty good basketball player. And then the last several years, I've written quite a few books for O'Reilly. And then when I moved to the Bay Area, and this was maybe 2008, I built a social media company from scratch. That was a sports social media company. And we got millions of users. Ultimately didn't work out, but it did give me a very good perspective on MLOps because we built many different machine learning products. This was 2013 or so, and we put those into production. We used Python, Erlang, C#, and R. So we had a lot of languages, and obviously JavaScript. And then after that, 2016 or so, I started to do consulting. And from about 2016 to 2022, now I've been doing consulting and teaching at multiple universities. I'm currently in North Carolina, but I'm kind of all over the place. I feel like I'm a global citizen. I'm definitely a fan of Europe, Canada, New Zealand, all over the world. I think is there's lots of great places to live. And then recently I wrote the book Practical MLOps, and I'm working on another book for O'Reilly on C# on AWS. So that's my background. Now let's talk a little bit about MLOps. First thing I'm going to cover is why MLOps. What's the point of MLOps? The use cases of MLOps. We'll go into a little bit of coding, and then we'll do a Q&A, and I can even do more coding after that. But to start with, I think, why MLOps? I think this is a very good question. Having taught, I would say maybe 1,000 people, maybe more with in terms of data science, I've definitely seen there is a need for doing MLOps. And I think this is a very important consideration. And part of it is that if you look at things like COVID-19 crisis, it really has revealed the need for being able to adapt quickly. So let's say in the future, hopefully it doesn't happen, but in the future, let's say 10 years from now, there's some new crisis. Could we rapidly identify the signals that are coming and use machine learning to maybe get a better handle on things, get better drug discovery? I think these are some of the things I think that are showing that our society may need better tools and better operational capabilities. And that to me is, I think, part of what MLOps is. And then how do you get started with MLOps? I think this is a great question for people. And I would say the foundational component is you must have DevOps. And we'll get into this in a second. But if you don't have DevOps, you can't do MLOps. You need to have a ability to do continuous integration, continuous delivery. Once you have that, then MLOps, it really makes a lot of sense for your organization because you already understand how to continuously improve things at scale. And one of the things I actually mention a lot to students when I evangelize MLOps is as I tell them or evangelize instrumentation, logging, the kind of the operational best practices, I say, if you're data science students, don't you understand that data is one of the most important things to use to make decisions, right? Like of all the people that would know how to make good decisions around data, it would be data scientists. So if you put something into production and you're not looking at data, I mean, how can you call yourself a data scientist, right? And so in one way you can think about monitoring and instrumentation as data science for software engineering. And we're going to talk a little bit about the major MLOps platforms as well. I think this is an area where there's I think a very good use case for using things that other people have built. In the case of AWS, you could use SageMaker, Azure, Azure ML Studio, Google Vertex AI, other third-party platforms. There's a company that I have been dealing with, Guazio, that has a great MLOps platform. There's Databricks, they have an MLOps platform. There's lots of platforms. I think platform is probably the way to go as well, because there are some features that are really difficult to do by yourself, like retraining in Feature Store. Okay, so where are things headed? Well, Wall Street Journal October 6th, 2020 said that there was 775,000 jobs in cloud, up from 400,000 in 2019. Now, 2022, who knows? I mean, the job market is just bonkers because there's so many companies looking to hire people. And if you look at what's happening, though, I think this is very interesting, is that you see that the data science is going down, and you see machine learning engineer is going up, and you see cloud is going up. So what is going on? Does it mean that data science is a bad degree? Well, I teach in at least 3 data science programs at UC Davis, Northwestern, Duke. So I don't recommend you don't that it is a bad degree. I think it's a great degree to get, but it's just be aware that it's in the context of a problem that you're solving. And so cloud computing, data engineering, machine learning engineering, I think these are really the areas where there's just tremendous growth. And what data science could turn into is it's a capability inside of a domain expertise. And I think there's a huge demand for people to be data scientists, maybe as a functionality of their job. The job title, I think, is less clear because of all these other job titles that are out there, including machine learning engineer or MLOps person. So what is DevOps and MLOps? Well, as I mentioned earlier, if you don't have DevOps, you can't do MLOps. I mean, that's not even possible. There's the famous Maslow's hierarchy of needs, where he had done research on how do you become a fully actualized human being and live to your potential. Well, you first have to have the basics, which are food, shelter, safety, those kinds of things. So likewise with MLOps, how can you do it if you don't have some of the basics? The basics would be DevOps, right? You do continuous integration, you have continuous delivery, you have high quality code where you're constantly improving your software engineering best practices. Once you've got that, then the next step would be, okay, well, what about data, right? Or can you move your data automatically? Is it clean? Is it sanitized? Is it maybe in a feature store somewhere? And then can you use platform automation? If you're building all the stuff yourself, you're going to be spending all your time building MLOps platform, not doing MLOps. And I think this is a really good way to think about things if you're having problems with getting MLOps into production. So let's talk about continuous delivery in particular. I think continuous delivery is an interesting one because really the idea here is that because of the cloud, and the cloud has the concept of complete virtualization, you can create an infinite number of environments. Really, there's no penalty to creating new environments. It's just a file or a config file or infrastructure as code. And so your GitHub repository, it could have, a main branch, a staging branch, a production branch. You go through, you build your code, you deploy it automatically into any of these branches. And because you're using infrastructure as code, you can actually programmatically, deploy things in a way that's safe and that is idempotent. So that no matter how many times you do the delivery, it'll always have the same effect. And this is really a capability that's not available unless you're using the cloud. And with a physical data center, the problem with it is that you're going to have to, at some level, not be able to do full virtualization or full abstraction because they're at some point it's physical hardware. And I think this is really one of the key things that MLOps gives you is, when you're able to tie on top of the DevOps best practices of cloud computing, you can do a lot of very interesting things. So data ops, I think, is a very good concept as well to think about. One way I like to describe this is to just think through the hypothetical situation where you wanted to build a city from scratch, right? Let's say you're building a town. I think I heard recently that the SpaceX people were building a town in, somewhere in Texas, and they don't have water. And, there's all these like technical problems, right, with building a town. I think one of the first things you need to do is, do I have water? And if you really think through the problem, though, it's not just that the water comes in, it's also the water coming out, right? So you need to have sanitized water to build a town. You also need to have sewage system to treat the water so it doesn't create a mess. Similarly, if you then start going further and say, well, okay, well, I want to have a dishwasher and I want to have a shower and I want to have all these modern things. Well, you need to have the inputs and the outputs all set up, or you can't build these things. Likewise, if you go to MLOps, you can't build machine learning systems if your inputs and outputs are not automated and have high quality, sanitized inputs and the ability to treat things on the way out. So if you think about cloud computing, the data lake in particular, which is the concept of infinite storage, where you don't have to worry about CPU and disk IO, it must be there, right? This is like the water. This is like the water hookup. And once you've got that, then all of a sudden these things become available. So you can do periodic data collection. You can do feature store. You can do serverless data engineering or event-driven development. You can also do model versioning because your big data system is able to take the things and work on them in place in the data lake, and then when it's done, create the model, put it back into the data lake. So really, this is a very tricky area that it's easy to kind of think about, oh, well, I don't really need this because I'm looking at notebooks or I'm looking at Kaggle or something like this. But I think the best way to think about it conceptually is, could you build a town that had modern dishwashers and washers and dryers and things like that if you didn't have water input and water out? No, you couldn't. So how could you possibly build machine learning systems if you don't have data in and out? So platform automation is really now the next step, which is, okay, let's assume we've got all that working. We've got DevOps, we've got the data, we've got all that working. But now, what code do I really want to do myself? And this is just maybe we don't even need to go into all the details on every single part of this graph because there's a lot of stuff going on. But if you think about the traditional data science workflow, we have ingestion, we have exploratory data analysis, you then do modeling, and then you do a conclusion. And in this scenario, it kind of seems simple. It's like, oh, great, I just ingest data, I explore it, I model it, and I make a conclusion. But in practice, depending on the size of your data, there could be a whole orchestration of distributed computing happening. So in the case of SageMaker, and this is actually something I architected out from a real SageMaker project, you first go in and you pull the data from S3. So first you have to have something that's powerful enough to store all your data, right? So, and then second, your platform has to be able to communicate seamlessly with the place you store the data. And so in the case of Amazon, SageMaker and S3, they work very well together, and it can handle that throughput of going back and forth. Then when you want to start doing exploratory data analysis and you want to start training, let's say, a principal component analysis model or a k-means clustering model or both, and combine them together, you may spin up 3 machines or 6 machines or 10 machines or 12 machines. And do you really want to write all that code that manages all that stuff? And once the training job is done, you learn how to make the machines go back down again. So this orchestration process of just the training itself becomes something that it would be better if your platform itself was able to handle it. And I think that's a really important thing to think about. And then when you're done and you want to serve the model out, if it's an online model, so you want to serve online predictions, then you're also going to need endpoints, and they're going to need servers, and they're going to need load balancers, and they're going to need virtual machines. And do you also want to manage those things? So in a nutshell, I think if you look at something like Kaggle or Colab or Jupyter Notebook, yeah, in theory, they're solving some of the problems. In the real world, though, you're not going to be doing that. You're not going to be just looking at a notebook. You're going to have all this orchestration in the back, sitting there going through things. And so I think it's, for most organizations, they're really going to be well served to pick some platform that does most of the work for them, because this is really not in your best interest to be writing all this code yourself. And I think that's just a very good intuition to think about is do the work on the things that differentiate your organization. Don't do work that is really kind of throwaway work. And that's where the platforms come in. And I'm not necessarily telling someone what platform to use. Whatever platform you pick, just use the platform. Don't necessarily write the code completely yourself. So now we get into the feedback loop for MLOps. And this would be, well, how do I actually now do something in production and respond to it. And this is where I think things are very interesting that are also not really talked about in terms of like academic data science or Kaggle projects. Is in the real world, I think people really do care about the feedback loop, right? They want to deploy the model into production, and they're not done, right? That could just be the beginning, is that after they deploy the model into production, they want to look at what's happening to the customer. What is the inputs that are now going to come back in so that we can retrain the model. Are you able to continuously deliver new models? Let's say you have a better, hyperparameter, or you have better data or whatever. Can you go through and retrain the model, observe what's happening, and then even use techniques like data drift, which is an emerging technique where you look at the percentage of data that's changed and you say, oh, look, we actually need to retrain the model. The intuition behind the data drift, I think, is very suitable to talk about COVID-19. So if we look at what happened the last several years, the brilliant scientists that came up with the COVID-19 vaccines were, it's amazing really what they did. But then they put their model, right, which is the vaccine, they put it into production, and then the COVID-19 virus didn't just like stay there, right? It mutated. And so now their model is slightly different. And so I think that's a good intuition, which is like in the real world, things mutate, they change. And so then you have to be observing, like, how much of a change is there? Do I want to retrain? Do I want to redeploy? And so I think the best MLOps systems know that things will change. They don't statically just put something into production and say, okay, I'm done, and then they walk off. Is that the system has to be designed for continuous improvement. And this goes into something that many DevOps people already know. You can't just deploy software into production, walk away. You're constantly going to be updating it. So it's very, very similar, I think, to what people are probably already familiar with in terms of DevOps, is that you need to design a system that is dynamic and can respond to changes and feedback so you can constantly retrain the model. Another thing I think that is a very good capability for organizations to think about with MLOps is this concept of create once and deploy many. So many organizations probably have like an Android app and an iOS app and a web app. And I think many companies have tried to figure out ways to maybe keep all the core logic in an API, or do things that build abstractions. So I think the same thing goes with machine learning, is that many of the platforms that you're going to use are actually pretty good at going through and building out the same kind of an ecosystem that can be deployed to all these different endpoints. So if you use a machine learning platform, most likely it can create a model that can be served out via an API. It also probably can be served out via container. It also can be served out via native mobile. It also can be served out via a JavaScript SDK. It also can be served out via some kind of edge device. Like, this is a Coral TPU right here that I could, just download some model, put it onto it, and it could go through and put this thing into production. So why build something bespoke for each one of those things? Why not use a platform that allows me to create once and then deploy many? So I think this is a very important concept to be aware of. So this is something that I've come up with that I don't know if other people have said the same thing, but this is my approach on MLOps, is that I've heard some people say things are data centric, or they're machine learning centric, or they're algorithmic centric, but my opinion is that actually there is no silver bullet, that actually it's a combination. This is my definition of DevOps, is it's 25% DevOps. You must have DevOps. You must do continuous integration, continuous delivery. It's also 25% of the data. If you don't have any data and it's not clean, it's not automated, then you can't build MLOps. Likewise, you can't do machine learning without a machine learning model. So, right? So you need some component. And then I think this is the other part that really is oftentimes, not taking, people don't look at exclusively, is that what is the business problem you're trying to solve? If you haven't framed the problem in the proper way, you may not be able to do MLOps because your company doesn't know how to use the thing that you produced. And so this is where the data scientist or the product manager or the ML engineer really needs to be very careful is that you could do everything right. You could do the DevOps right, you could do the data right, you could do the model right, and then it turns out you built the perfect machine learning model that nobody wants. And so you also need to have the ability to frame the problem correctly. And this is why I think MLOps is so difficult, is that each of these require very different people. And a lot of times it's very difficult to find someone that understands all four. And that's why if you look at things like the Zillow house flipping issue, it's like, well, not necessarily surprised because it sounds like they probably were very good technically, but they may have had a problem on the business end because they could have framed the problem in a way that wasn't going to make them successful, right? If they framed the problem in a different way, maybe they would have been successful. And it's a very interesting problem. And that's why there's a lot of money to be made with MLOps because it isn't fully sorted out yet. I think there's a lot of people that are working on ways to make it better and better. Okay, so what about some MLOps use cases? Well, we know some of them. I mean, we've heard about many use cases. Autonomous vehicles, I think, is one of the more popular ones. And I'll briefly talk about that because I got invited to go to Palo Alto a few months ago to visit Tesla. And, I'm definitely impressed with the Tesla people. They're very intelligent, motivated, conscientious engineers working on all kinds of, really great technology. I think that one of the big issues with things like autonomous vehicles, and I mentioned this in person, what I said to them is that I think we're going to have some ethical issues where there is a way to train autonomous vehicles in a way that would not have negative externalities for people that have decided who haven't chosen to participate in the experiment. So, for example, if you're a pedestrian and you're walking across the street, you didn't sign a waiver that says you want to be part of Tesla's autonomous training, system, right? That's a negative externality. You could phrase the problem, and I did say this to them. You could frame the problem in a different way that, in my opinion, would be more ethical, which is you would build a dedicated road and only Teslas could get on it, and only the people that agreed to be part of the beta test could be on a dedicated road. Now, it would be much more expensive and potentially would take longer to build, the L5 level autonomous driving. But I think these are the kind of ethical things that people are going to have to deal with autonomous vehicles. Next use case would be implementing MLOps in production from zero. I think this is a very interesting one in terms of that if your organization is hiring a bunch of expensive people in ML and data science, this is really one of the use cases is that I think that people do need to have a sense of urgency and they do need to build something very, very quickly so that they can show results. And I think this is definitely a use case for MLOps is, if you can't get something into production and deploy, I would say maybe on a daily basis, updates to your machine learning system, then I would say you're not doing MLOps and you should rethink what you're doing. Next use case here is applied computer vision. This is really a dynamic area that is under rapid development. And in terms of applied computer vision, we're seeing things where people are using even pre-trained models that are very, very good that can do labeling and solve business problems. And so I think we're going to see a lot of use cases for MLOps in this, in that there may be some organizations that don't even care if they train the model themselves, or maybe they're doing things like, using other techniques where they can use a pre-existing model and just tweak it a little bit. But in general, I think computer vision is a great place for people to do MLOps. And I think this concept of real world reliability versus, the research environment, many academic environments are doing research or written research papers. Ultimately, there's going to be a need for people to put things into production. And this is where I think MLOps comes in, is someone could take a lot of the research and then operationalize it so that there is some kind of ROI on that research. Okay, so that's the background of MLOps. So let me just show you a little bit of coding here for MLOps. And so what I'm going to do is I'm going to go to a notebook here that's or a GitHub repo that's intentionally very, very simple. MLOps notebook, and I'm going to just walk through it. So let's see, here we go. MLOps cookbook here. And so the idea with this cookbook isn't that it's an advanced MLOps example. It's actually the most simple example I could possibly come up with really toy examples to basically illustrate the principles. And so a few different things I'll point out here. One, in this particular repo, which is Noah Gift MLOps cookbook in GitHub, that I have a GitHub Actions set up here. So this is where the continuous integration would be set up, where I could do the installation of my software, the linting of my software, the testing of my software, the formatting. Now I also, and this is just an example of one of the things you could do, is I also build out a container and I push that container somewhere. Now, depending on what kind of system you have set up, many continuous delivery systems will actually listen to the container registry, and that's how the whole deployment process works. In fact, AWS App Runner works very well with that scenario. Is as long as you push the container to App Runner, it'll do the deploy. So this is really one of the foundational pieces, is some kind of build system that can deploy your code. The other component that I think is almost always going to be involved in especially a microservice based MLOps deployment is you're most likely going to have some kind of a Docker file. Again, this is an intentionally very, very simple Docker file here. We have, a microservice, it's copied in, and then I have an endpoint that exposes this microservice. The other thing I think is obviously the microservice code, right? So here's an example where I have some Flask code and I create a very simple route. Again, intentionally simple, but this is just a predict route. I have a post, so it takes a JSON payload. The JSON payload comes in, and I just do a machine learning prediction. Now, in this example, you see that I do MLlib. What I do is I built a toy repo here inside of MLlib right here. And this MLlib is just essentially a library that lets me do things like load the model off of disk or, read some data. Now, in some cases, I think the framework is going to do all this for you. And it's almost like too much code in a sense, because I wrote all this from scratch. I think many of the MLOps frameworks that you're using from a platform do a lot of this stuff for you, but you may have to retrain a model. You may have to format the input, scale the input. Most machine learning models require you to scale the data, because machine learning really is about numerical data that's scaled for the most part. There's a few machine learning techniques like decision trees that don't require scaling, but for the most part, it's going to be scaled numerical data. So we scale it, and then you go through and maybe have some helper functions that convert things from inches and feet to some other format, makes human readable payloads. But the gist of the things here is that I can call all of this code just by going through here, and in one line of code, I just say predict. So, I mean, that's really the essence of whatever it is you're doing with MLOps. Is you have containerized microservice that continuously deploys, and you got a library somewhere that imports and it does a prediction with the model. So let's go ahead and check this thing out somewhere. So what I would probably do is a good place to start is I'm going to go to code, and I'm going to see SSH here. I'm going to copy this. And I really am a fan of Cloud9. And what I like about Cloud9 is that it is a great environment for building services in the cloud, because you're typically going to be deploying services in the cloud. So why not build and deploy in the exact environment that ultimately your production deployment will go to? So for me, this is one of my favorite ones to use. And I'll just show you how simple it is to get started and why it adds a lot of advantages. So, what I would probably say to start with would be, you go through here, and I just do a git clone. Go through here, pull out MLOps cookbook. Great. The first thing I would set up locally here would be that I would probably create a Python virtual environment. We'll go through here and do that. We'll just say Python virtual environment -venv. We'll call this .mlops. Once I do that, then I just need to source it. And then really it's pretty simple at this point because I use a make file. It makes my life very easy. I can just do a make all, right? Because I have installation, linting, testing. Let's go ahead and test it out. If this doesn't work, you're in trouble, right? Something's broken. If it does work, there's a really good chance that everything will work out pretty well. So let's go ahead and take a look at this. And this should install very quickly. And here we go. Installation looks like it's almost done. All right, now I'm doing a lint. I'm just testing my library, my command line tool, some of my utility code. 10 out of 10, great. Now I'm doing test coverage, great. We got everything working here. It looks pretty good. So what I can do is actually first run my Flask app in foreground mode. So let's go ahead and do that. We'll just go Python app here, run it foreground mode. Now this one, not sure why that particular, maybe it had a change in the library. That's always fun. That's what I get for not doing a probably a requirements. I probably didn't pin my requirements. No, that's weird. I'm not sure why that doesn't work. Cannot import name in JSON from It's Dangerous. That's weird. Python. Huh. Or you know what it is? I'm using the wrong Python, maybe. No. Huh. Not sure why that thing's actually having a bug, but fortunately we can actually fix this because I built this earlier and there's a Docker file. So that's one of the advantages of Docker is that we know it at some point it worked. So I can just scroll down to where my Docker file is and I'll just do a Docker pull and we'll solve that problem the easy way, which is, let's just look for the word Docker here. Docker. There we go. We'll just do Docker pull right there. Let's do that. And the beautiful thing about Docker is at one point it did work, right? That's what I like about Docker is that it means that at one point you built something that worked and that's why you pushed it into a container. So now if I do Docker image ls, we should be able to see this Docker container here, which is this one right there. So we should be able to say Docker, just double check my command here. I like to be lazy and just do we'll do this. We'll do Docker run and we'll just run the exact same command, Docker run. And then this particular container with latest. And there we go. We got it working. So Docker build us out here. And now I can use the other stuff that I had, which is I wrote a little test file here, which is, let's see here, predicts right here. So if we look at this predict, this is something I like to do sometimes. Just build a very small, prediction here that, goes through and lets me do a smoke test for my machine learning model. And so we go through here and we do a predict just like that. There you go. And we see it works. And if I look into foreground mode, we see this is running. So I think one big takeaway here is that the container itself is, I think, the ideal scenario for most machine learning models because you've kind of pre-validated everything, and it's just yet another solution that eliminates some of the bugs. Like, I don't know, no clue. I don't even care about debugging that problem right now, but a container is pre-baking both the runtime as well as the model itself. And let me show you why that's so important is that some of the new, environments in AWS have great support for that. So one of them is something called App Runner. And this is becoming, I think, really like an emerging technology for doing MLOps are these kind of PaaS platforms. And let's just first look at what App Runner is. Let's see if they give me like a. It's a bummer they don't give me the overview page here anymore for App Runner. But anyway, we can just create a new App Runner project, and notice what's really cool about it is that you can actually give it a container registry. And so what's neat about this is that I can actually tell it some location where I pushed it into my Amazon container registry. And then I could go through here and select it. And we could just, I'm just going to pick something I did recently. Like, here we go. There's a fast API application I built. We scroll down here and you can select automatic. And this is what's so great about this is if you have your build system going through and testing your code, building all the package together, taking the machine learning model, maybe the latest one that's been versioned, slurping it all in, pushing that into the Amazon container registry, you then just go here, click automatic. Then you select your role, you go through here and you call this, MLOps container or whatever you want to call this. And the only thing you really need to configure is the container registry and then the port. That's it. And once you click this, we go through here and we just say next, and we just say create and deploy. And now every time I push a new container to my container registry using the build system, it'll automatically deploy my product into production. And just to show you like what this looks like, here's one I ran recently. And you can see here, this is just some toy app that I was building, but basically, you can build out these microservices, and they're basically production quality microservices that have logging, metrics, configuration. You can do custom domains, and really the heart and soul of this is that I'm leveraging the AWS cloud, plus I'm leveraging the concept of a container. And so I think this is another big key takeaway is building on top of DevOps along with containers and high-level services like AWS. I think are really the secrets to building MLOps techniques that work in the real world. Okay, so that's probably a good spot for me to stop and see if anybody has any questions, and happy to do anything else from here.
Thank you, Noah. And I'm going to bring Zuk, who's going to be our moderator for questions. I'm going to remind everyone that you can ask your questions in the YouTube chat or on Slack. If you're on Slack, we are in channel meeting, and we're going to relay them out loud to Noah.
Okay. All right. Thank you, Noah. Pretty cool. I have a first question from Jean-Philippe Brochure. Is there a particular learning path you recommend to order to learn DevOps and MLOps?
Yeah, I mean, I think that the bias side of me would say read both of the books I just wrote, because I did write a book called Python for DevOps, and then right after that I wrote a book called Practical MLOps. So I think that actually would be a good order, is go through both of those books. But even if you don't read the books, I would say that the order would be that from a high level, I would say making sure you understand how to do DevOps, which is continuous integration and continuous delivery with containers. Once you know that, then you just need to know some data science. And for data science, I think the key takeaways are that there's a lot of tutorials for data science on the internet, but you don't necessarily need to know all of it. You just need to know that the idea behind machine learning is you're doing predictions, and you need to build those predictions into your DevOps product. So for MLOps, I think it is possible to not be an expert at data science and still be pretty effective very quickly. So it's possible you could do MLOps 3 to 6 months from zero. I think it's very possible.
Okay, cool. Yeah, but I think the mindset is pretty important too. Like you have to have you want to automate everything. So because me when I start to learn DevOps, I have to have the mindset that I don't want to repeat the job, and I just want to do everything automatically. So
Yeah, automation. I agree.
Mhm.
Automation, and I would say that using the highest level tools available. So
Mhm.
like the platform as a service, the containers, and also build systems, those are really critical for MLOps. And
Okay.
also, I think AutoML, I think is another one. AutoML or pre-trained models. I think many people should be using AutoML.
Okay. Good. Yeah. Okay. I have another question just come in here. Does App Runner take care of scaling your ML workload?
So App Runner is just a platform as a service offering, and so you can make it scale absolutely. So if you want to configure your system to scale to a certain capacity, it'll automatically scale up and down based on the traffic you give it. So I think it's a very good service for building microservices because of the fact that literally you just give it a container, and the container, like I think I mentioned this earlier. I'm writing a book on C# right now. It works very well with C#. It works very well with Python.
Okay.
Anything that can run a container, you just put it in
Mhm.
there, and then it uses all of the AWS resources, like load balancers and auto scale groups and all that stuff automatically for you. So yes, it absolutely can auto scale the requests.
Okay. Thank you. Yeah. Yeah. I mean, when I started to learn Docker, I had a lot of bad experience because in the days Docker was not really stable. But now, I mean, you don't have a choice,
Yeah.
Yeah, if you want your apps to work, you need to use Docker. Let me see if I have another question from the audience, or if not, I have. You talk about your job at Disney. What kind of data do because me, the only data I know is just JSON and on kind of that, but in the film industry, I think it's gonna be
Yeah, so this was 2004 when I worked at Disney Feature Animation. This was in Burbank, California,
mhm.
and they in the film industry they have big Linux clusters. At least when I was working in the film industry, Linux clusters. Everybody has network file system as well, and so the data is actually images, and so they have
Okay.
very large images, and your job is to actually convert those images into multiple kinds of formats. And so it is actually very similar to some of the things that people are doing now. And so you write tools that will other people can use to do their job as an animator, or take a series of files and convert them into a movie, or add some kind of effect to a file, or copy the data automatically from one location to another location, convert it to different formats. So a lot of scripting automation happens in the film industry, and I would say probably 90% of the code is Python. I mean, there's C and C++ and languages like that, and maybe a little C#, but really 90% is Python because
Mhm.
people use it to script.
Yeah. Okay. Thank you. And also, we talk a lot. You talk a lot about the platform and all of that. Do you know any open source like MLOps platform that we can?
Yeah, there's actually a company that I'm an advisor to called Iguazio, and
Okay.
they build a really interesting open source MLOps platform actually called ML Run. And I'll put it into maybe like here,
Okay.
so you can give it to other people. But
Yeah.
basically, ML Run is built on top of Kubernetes, and it's actually very interesting. And I think that's one of the more interesting emerging MLOps platforms is ML Run.
Okay. Yep. Okay. Just let me see here. Okay, just let me take a tour to see if I don't miss any questions. But I think we are good to go to bring up Yannick to come back.
Thank you so much, Noah. Will you be able to join us for the happy hour? Maybe just for 5-10 minutes. So we're just gonna open a different video conferencing platform so that the attendees can join us.
Sure.
And in a more relaxed environment, maybe ask you more questions, or you can just tell us about your day. That's always fun to do in a happy hour.
Yeah.
Excellent. So I will remove Noah from this live stream, and just the closing word. Duc, what do we have to tell our audience now?
Yeah, I think you already tell. We have all events are coming, and yeah, I think that's it. We think you just invite everyone to Senkaset, and then we can continue to chat there.
So it seems like I didn't forget anything important in my intro speech. Everyone, all the links that I mentioned in the intro speech are in the YouTube description, including the link to the happy hour. It's called Apéro Virtuel en français. On va se voir, allez vous chercher une bière, un café, peu importe quel rafraîchissement vous rend le plus joyeux. Et, eh bien, je vous souhaite que cette semaine, le serpent vous apporte beaucoup de gaieté dans votre code.
Ouais, ça c'est cool ça.
À plus tard tout le monde.
Oui, à plus tard. Merci, bye bye.